Inference about two means, dependent samples, dependent. We'll do independent next, but this is about dependent samples. I keep calling this 11.2. Again, that's from a different book. Just ignore that. Enjoy the videos.
Hey folks, we are moving on to 11.2. It's called Inferences About Two Means, Dependent Samples. Dependent samples. I usually just like to say matched pairs because the data is sort of matched up. Stay in focus. Okay, so I'm looking at problem number 1, and they're talking about the SAT. They got 7 people there, and so the Princeton Review is supposed to help improve SAT scores. And so let's see, we have the before and after score. So you see how it's on person number 1, they took the test before and after the Princeton Review. So notice that the first person, their score improved by 10. The next person, their score improved by 20. I'm just subtracting down. The next person did worse, negative 30. And then the next one did better by 10, and then 20, and then 20, and then 30. 1, 2, 3, 4, 5, 6, 7. Okay. So we would take this data. So notice basically the whole idea of 11.2 is just subtract first. And then it's just going to be the t-test like we were doing in 9.2. So we get this data, and we're going to throw it into our calculator to get an x bar and an s. So we throw this into our calculator to get an x bar and an s. But because these were differences, right, in order to get these numbers, we had to subtract to get the differences. So when we get the average of these, instead of calling them x bar in this section, we call them d bar. And if we get the standard deviation of all these differences, instead of calling them s, I guess our calculator calls it s sub x, which is s. So the standard deviation of all these differences is just s sub d. So conceptually, there's really nothing new going on. I kind of wrote it up over here. Let's bring this over here. So in 9.2, we learned the t-test. Now here's our new formula for the t-test. It's basically the same thing. Remember, x bar is just d bar. And then what if the mu sub d, what if we're always comparing it to 0? Remember, 0 is the idea of no effect. So we're wondering if the Princeton Review has no effect or if it has an effect. So that's why the formula they're going to give us in 11.2 is actually this. So it's technically just our t-test, except the mu naught happens to be 0. They call it mu sub d in this section. They're really trying to complicate things. 11.2 is totally easy. They try and make it seem complicated. It's just 9.2 all over again. First step is you subtract. Okay. And then when we want a confidence interval, this is what we used in 9.2. So we used a t-test, and we used a t-interval. So we didn't really even, we used the formula once, and then I just showed you how to use the calculator. So again, everything looks basically the same. Instead of s, it's s sub d. Instead of x bar, it's just d bar. So we're just using a t-interval again. We're just using a t-test again. So don't we know how to do that? Yeah. Don't we know how to do that? Yeah. Oh, so in 11.2, every section, there's new minimum requirements in order to use these. Well, they're the same formula. So it's basically the same basic minimum requirements we had for 9.2. So just go to page 537 and 11.2. Just double check that they're met. So on 537, what does it say? Sample is obtained by simple random sample. Yeah, we know that. From a matched pairs data design. Okay, so that's the one idea that's new. Make sure that the data is actually matched. Like, is it one person, 2 scores, another person, 2 scores, right? So in our first problem, person number 1, 2 scores, 990 and 980. Subtract them. And then, let's see, the differences are normally distributed. N is greater than 30. And then our sample is less than 5% of the population size. So there's sort of the standard minimum requirements. Take a look at those on page 537. We're going to proceed forward with assuming minimum requirements are met. So going back to problem number 1. Step number 1, do a bunch of subtraction. Okay. And now we're just going to throw it in for a t-test. Let's see, where'd my black pen go? HO, HA, H1, same thing. Oh, okay. So they always kind of slightly mess with our null and alternative. We're talking about differences, and we're wondering, the null is just if there is no difference, if nothing's happening. So rather than just saying mu equals 0, they like adding a little d. Mu sub d equals 0. Is the mean of the differences equal to 0? And then the mu sub d, okay, greater than, less than, what do they want to know? Did the Princeton review improve scores? So is the mean greater than 0? This is a little tricky. Notice how the way I set things up, if you just subtract down the before and after, so after you took it, your score went up. So if you just subtract down, this is how your SAT score improved. So I'm curious if the mean is greater than 0. If these numbers are greater than 0, then that means your SAT score got better. And that would mean that the Princeton review actually works. A little tricky. Let's see. So I think it's just a matter of throwing everything in our calculator now. Test that, p-val, statistical conclusion, in plain English. Okay, so I'm just going to throw these numbers into my calculator. Let's see, on, get a little bit more light. Let's see. Oh, putting numbers into a list. Okay, stat, edit, enter. There's numbers already there. Go up, hit clear, hit enter. Okay, 10, enter, 20, enter. Negative 30. Careful, don't put subtract. You have to use the negative. Negative 30, enter, 10, enter, 20, enter, 20, enter, 30, enter. Okay, now we're going to do just a t-test. Stat, tests, it's just a t-test, enter. Did we give it raw data or summary statistics? We gave it a bunch of raw data, so choose data. The mu naught. What's the mu in my H naught? 0. Okay. Is the data in list L1? Yes. So put L1 there. Frequency. Every number just shows up once. Just put a 1. And the alternative, we have a greater than symbol, so choose the greater than symbol. Enter. Go down to calculate. Hit enter. Okay, so we have a test stat of t equal to 1.549. Oh, that's why he got mad at me last test when I didn't put z equal. I just put the number because it's going to be different. Sometimes it's z, t, f, w. There's all kinds of weird things. So make sure you write the letter. T is equal to 1.549. What's the test stat? It's t. T is equal to 1.549. What's the p-val? 0.086. How does that compare to our alpha? 5% significance level. How does that compare to 0.05, which is our alpha? It's greater than. If p-val greater than alpha, we say do not reject HO. So far, so good. It's the same game over and over again. You just need to know how to set up your null and alternative, and then it's just understanding the output from your calculator. Okay, if it's do not reject HO, then I say not enough evidence to suggest. Not enough evidence to suggest that the mean difference is greater than 0. And what was that trying to help us decide? Whether or not the Princeton review increases SAT scores. So not enough evidence to suggest the Princeton review, if you want to put it into sort of the context, the Princeton review improves SAT scores. Do not reject HO. Do not reject HO. We're stuck with the HO. There's not enough evidence to suggest this. There's not enough evidence to suggest that the mean difference is greater than 0. There's not enough evidence to suggest that the Princeton Review improves SAT scores, right? Okay. Let's do another one. Hope that made sense.